The pressure, all right? And the book actually talks about this, how there are so many different units that get used for pressure. It's kind of maddening, okay? But what we want are atmospheres, okay? ATMs. So the pressure on the weather report is expressed in inches. So we're given a factor, okay, to be able to convert this, all right, into atmospheres. These are ATMs. So that's one calculation. We are doing a number of calculations here. This is the one to get the P. All right, P is going to be in atmospheres. All right, V, our volume, is going to be in, we're using decameters cubed, which gets basically, or liters. They're interchangeable under the metric system. That's why we use the metric system for science. Okay, so that's the V. All right, so it is confusing. They're not all going to be the same units. Pressure is being measured here in atmospheres. This is going to be liters. Temperature is in degrees Celsius, right? Okay, so we're just kind of having to keep everything in, keep track of your units. So that's why this handout I gave you actually provides a lot of room for you to take notes and make sure that you're writing everything down in an orderly fashion so that hopefully when you come out of this you understand what's going on. Yes?
Don't we have to convert the Celsius to Kelvin?
Yes, and I think that's on the, it is. Okay, so if you look, you guys have this handout, right? Okay, so we've got the pressure, so we're going to come up with this pressure. Yes, you also, the last thing, this is a standardized formula, right? And she's right that we measure in Celsius, but the formula uses kelvins. And the book actually does, I think, a fairly good job of explaining why. Because it tries to get back down to that absolute value. We can't do that with the Celsius scale. So that's why you have to add, is it 273? I think, yeah. And you don't have to, don't worry about the 0.15, just 273. So our Kelvin scale is just simply going to be adding that 273 degrees to the 26, okay? So if I do my math right, I get 299, correct? Degrees Kelvin, okay? So that's going to be the T. This is, and of course my handout is a little more tidy than this one. This is going to be the P. This is going to be the V. Your V, everybody's V is going to be a little bit different because everybody had a different balloon, right? Okay? R is given on your handout. Yes?
So we're not using the CO2 pressure? We're just using the atmospheric pressure?
That's another complication in this particular one. Yes, we are going to have to use, I've actually walked you through this calculation.
We found the CO2 pressure, so we're not using that in the formula. Because you have 1.003, which is the
They want us to pull out the vapor pressure, the water vapor pressure. Okay? So this is part of this maddening thing. Water vapor in your table is in these mercury units, right? Okay? So in order to convert that to ATMs, you have to take that number in your table and convert it to ATMs.
So you got that number, but I was just wondering, so we're using the atmospheric pressure in the formula and not the CO2 pressure.
Right.
That's okay.
Yes. So your atmospheric pressure, that's the 1.03 minus the vapor pressure will equal, yes, will equal the CO2.
But we're not using that.
Correct.
The radius is 0.93.
So no, you get 0.25
divided by 760.
Well, you take the atmospheric pressure, which is 1 minus
Okay, that would be what we're
so
299. Yeah, 299.
So what did you guys get for your water vapor pressure?
So the
then it's 0.4.
It should be a very small number.
0.970.
0.97.
0.9?
That's what I got.
That's what we all It's the atmospheric pressure, which is 1.003, minus the vapor pressure, which is 0.0332. And we get less than
Where are you
1.
using the 22.4?
But we don't, I don't have that number.
Why 2.4?
Oh, okay. Oh. Okay, so we have atmospheric pressure,
Yeah.
temperature.
Well, the vapor pressure.
Oh, don't tell me you have to use STP.